According to interpretations of the National Electrical Code, specifically sections 352.9 and 250.74, bonding jumpers are a necessity for Wiremold installations that house electrical receptacles. The rationale behind this stems from the fact that while metal conduit may theoretically serve as a grounding path, this isn't always reliable, particularly in Wiremold applications. Wiremold, due to its common installation environments, may not guarantee a consistent and continuous electrical path to ground. Therefore, simply relying on the metal conduit for grounding isn't sufficient to meet code requirements or ensure electrical safety. National Electrical Code Section 352.9 specifically addresses the use of metal raceways as equipment grounding conductors. While the metal raceway can be used for grounding, it needs to meet specific requirements to ensure its effectiveness. Firstly, the raceway must be mechanically and electrically continuous. Secondly, the connections must be made using fittings that are approved for grounding. Thirdly, the path to ground must be permanent and continuous. If these conditions aren't met, a separate equipment grounding conductor must be installed within the raceway. National Electrical Code Section 250.74 provides more specific guidance on bonding requirements, particularly for metal enclosures. This section mandates that metal enclosures containing electrical equipment must be bonded to the equipment grounding conductor. This bonding ensures that the enclosure is at the same electrical potential as the ground, minimizing the risk of electric shock. The bonding connection must be made using a bonding jumper, which is a conductor that connects the enclosure to the equipment grounding conductor. The size of the bonding jumper must be determined based on the size of the circuit conductors, as outlined in National Electrical Code Table 250.122. Therefore, even if the Wiremold raceway is made of metal and appears to provide a grounding path, it's still essential to install bonding jumpers to ensure compliance with the National Electrical Code. The bonding jumpers provide an additional layer of safety and ensure that the electrical system is properly grounded, reducing the risk of electrical hazards. By installing bonding jumpers, the integrity of the grounding system is reinforced, ensuring that it functions effectively and protecting against electrical faults. This is particularly important in situations where the metal conduit may not provide a reliable grounding path due to loose connections or corrosion. The use of bonding jumpers provides a direct and reliable path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Without proper bonding, fault current may take unintended paths through equipment or personnel, leading to electrical shock or fire hazards. In situations where non-metallic mounting brackets are used, the exception to National Electrical Code Section 250.74 cannot be applied, further emphasizing the necessity of a bonding jumper to a grounded box. This exception typically allows the metal raceway to serve as the grounding conductor, but it's contingent on a metallic connection between the raceway and the grounded box. Since the mounting bracket is non-metallic, the exception cannot be used, and a bonding jumper is required to ensure proper grounding. When installing Wiremold, it is recommended to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. They can provide guidance on the proper installation techniques and ensure that the grounding system is properly designed and installed. This will help to avoid potential electrical hazards and ensure the safety of personnel and equipment. Therefore, prioritize the installation of bonding jumpers in Wiremold systems with receptacles, reinforcing grounding reliability and adherence to National Electrical Code standards. Firstly, identify all metallic Wiremold sections that contain receptacles. Secondly, ensure that each of these sections has a designated grounding point or screw. Thirdly, calculate the appropriate size of the bonding jumper based on the circuit amperage. Fourthly, connect one end of the bonding jumper to the Wiremold grounding point and the other end to the equipment grounding conductor within the receptacle box. Fifthly, tighten all connections securely to ensure a low impedance path for fault current. Sixthly, inspect the entire Wiremold system to verify that all metallic components are properly bonded and grounded. Seventhly, perform a continuity test using a multimeter to confirm the integrity of the grounding path. Eighthly, document all grounding connections and test results for future reference. Ninthly, regularly inspect the Wiremold system for any signs of corrosion or damage that could compromise the grounding path. Tenthly, consult with a qualified electrician or electrical inspector if you have any questions or concerns about the grounding of Wiremold systems. Remember that grounding is a critical safety measure that protects against electrical shock and fire hazards. In conclusion, bonding jumpers are required for Wiremold installations with receptacles to ensure compliance with National Electrical Code sections 352.9 and 250.74. Do not rely solely on the metal conduit for grounding, as it may not provide a reliable path. Install bonding jumpers to provide an additional layer of safety and protect against electrical hazards. Consult with a qualified electrician or electrical inspector to ensure that your Wiremold system is properly grounded and meets all applicable codes and regulations. The metal conduit serving to ground the raceway does not eliminate the need for bonding jumpers. This is especially crucial in Wiremold installations where achieving a continuous electrical path to ground is challenging. It is recommended to install bonding jumpers in accordance with the National Electrical Code to ensure code compliance and safety. This practice is essential for passing inspection and maintaining a safe electrical system.